So the mean value theorem. There were two conditions. It's continuous on the closed and differentiable on the open. Continuous almost always goes with closed. I don't know when it doesn't. So for our purposes, continuous is going to go with closed. It's continuous on the closed, differentiable on the open. Our conclusion then is that somewhere on the open interval, and textbooks have A and B in there, but a problem might have 1 to 4 or 0 to 3 or wherever, but somewhere on the open interval, do you remember what's the main point of the MVT? There's like 3 different ways to say it. Okay. Calculus slope equals algebra slope, which is the same thing as IROC equals AROC. We'll keep them on the same side there. So F prime at C equals good old algebra slope, y2 minus y1 over x2 minus x1. So the mean value theorem just guarantees that somewhere on the interval you can find a C. There's a place where the derivative equals the overall slope. And the task, what they will usually ask you to do is to find C and then make sure it's on AB. Again, you have to exclude the endpoints, and that was the trick on one of the quiz questions, I think. So algebra slope equals the instantaneous slope somewhere. The extreme value theorem is even simpler. Probably should have listed it first. The only criteria is that it's continuous on the closed. So continuous on the closed interval from A to B. And the conclusion is there's a max and a min somewhere. It's kind of a dumb theorem. So as long as you have a continuous function, it can start and stop and do all sorts of weird things. But as long as it's continuous, you're guaranteed to have a maximum and a minimum. Because the only things that would make there not be a max and a min would be things like asymptotes, but then it wouldn't be continuous. If there was an open circle on one end or the other, there might not be a max or min, but it's supposed to be continuous on the closed, so the endpoints are supposed to exist.
You might just do it if they're also off, though.
So the mean value theorem is the big one. That one we use often, and it sounds like many of you remember it this way: IROC equals AROC, and then your job is to figure out where that is. All right, let's talk about first derivative stuff. So that would be f prime or y prime or dy dx. There's a couple of other less common ways to write prime, but we're not worried about those. let's see, f prime tells you the slope of f. Which tells you if f is increasing or decreasing. Which means you can find relative extrema. Right, that's where we do the number charts or number lines and look for increasing and decreasing intervals. It's related to critical points. That's where f prime equals 0 or undefined. And then the first derivative test for max and mins is if f prime changes signs, so if the slope changes, if it changes increasing to decreasing or decreasing to increasing, then f has a relative extrema. And if the problem says justify a relative extrema, or it might say relative min or relative max, might you say justify?
You circle your work and draw an arrow.
F prime changes from positive to negative or negative to positive depending on if you've got a max or a min. But you need to say that. You don't just like draw things and draw pictures. Like you have to say f prime changes from positive to negative or negative to positive.
That's just unnecessary work in my eyes.
All right, so all of that was first derivative stuff.
Yep.
Lots of stuff goes with first derivative. Second derivative. So f double prime or y double prime or d2y over dx squared, d squared y over dx squared, second derivative. So f, the second derivative tells you concavity of f. You can use it to find points of inflection of f, because that would be where the second derivative changes signs. And it tells you if f prime is increasing or decreasing. Right, then there's a second derivative test for max and mins. This is a little bit confusing, I think, to students. Well, the first derivative test for max and mins, I think most people are fine with, because that's the one we usually use. That seems to make sense. Increasing to decreasing, you got a max. Decreasing to increasing, you got a min. The second derivative test is a little bit weirder because we don't usually associate second derivative with max and min. We associate it with concavity. here's the test. If f prime equals 0, and then there's two options here. If f double prime is greater than 0, so if you think about what that means, again, this is not a memorized thing, this is f prime equals 0, so the slope is 0, and we are concave up. So we're at a spot on a graph where the slope is 0, but we're concave up. What's going on right there? A max or a min? A min. You've got a relative min. And then the other way would be if f double prime is less than 0. So that means f prime equals 0 means you've got a flat spot on the graph, but we're concave down. That means there's a relative max. So both of those are justifications or ways to find maximums and minimums. One of them uses just the first derivative. The second one uses the first derivative because you got to find where it's 0, but then you use the second derivative to figure out if it's, down like a frown or up like a cup. Let's see if this flowchart is helpful. So a lot of times we ask you to find critical points. That's where f prime is 0 or undefined. Critical points, that's the same thing as possible extrema. Might be extrema. And then to figure out if they're extrema or not, this is the confusing part because there's multiple things to do. So I'm going to give you a three-way fork in the road here because there's 3 different things you can do depending on the problem. You can make a table with endpoints. And if you do that, this was the last thing we did, that will tell you the absolute extrema. Because you're just looking for the biggest y and the biggest x, or excuse me, the biggest y and the smallest y. Make a table. But that only tells you the absolute extrema. You could do the first derivative test. That's intervals on a number line. So you're looking for increasing and decreasing. So that doesn't tell you like overall max and min. That tells you relative extrema. And then the last thing you could do is a second derivative test, where you find the second derivative at the critical points. And then you're thinking about concave down, concave up, and that also tells you relative extrema. So, to me, I think this is helpful because there's so many new words. They're related, but they're different because there's 2 ways to get relative extrema. It's not exactly the same as an absolute extrema. There's different ways to find them. And so there's just a lot going on here. And again, this sort of presupposes that you can actually find all the derivatives, like the derivative of sine, and power rule, and exponents, and all that stuff. Then you apply it to find maximums and minimums. One more thing, and then we'll work a few off the review together. This is what we started with. Combine f prime and f double prime to graph f. I'm going to try to make a table here. See if this... So f prime might be positive or negative. F double prime might be positive or negative. So if f prime, let's ignore the double prime stuff. If f prime is positive, what does that tell us about f? F is increasing. F is increasing. If f prime is negative, that tells us that f is decreasing. F is decreasing. Switch to a different color just for the heck of it. Second derivative. If the second derivative is positive, what does that tell us about f? Concave up. And if the second derivative is negative, f is concave down. And I tried to leave room in there to draw a picture of each one. So increasing and concave up, increasing, but concave up like a cup, would have to be something like that. Decreasing concave up, so we're going down, but we still want to be up. We still want to be decreasing, but bold up. Something like that. Bottom left, I want to be increasing, so I'm going up, but concave down. So down like a frown, but still increasing. Something like that. And then decreasing and concave down. So decreasing, but concave down. This kind of stuff shows up a lot if you've had calculus and you start paying attention to the news. They'll say things like the rate of inflation, the increase has slowed. You're like, well, is that a good thing or a bad thing? Well, prices are still going up, but they're not going up as much. So it's like, is that good or bad? You're like, well, I don't know. It's bad that they're going up, but at least it doesn't look like that. So close to. Did I blew that because these should definitely not look the same. Yeah, so decreasing concave down be like that. Okay, so that's a rough, large overhead view of the unit. Again, it sort of presupposes you can actually do all the derivatives. Take the derivative of sines and cosines and all the other things. Let's look at the review. I'm scared to ask now. Was that helpful? Did that clarify some things? Okay, it helped 3 people. Good. I'll take it. Looking at worksheet 5. Let's see. Mean value theorem, critical values. As you look through there, is there anything that I mean, are there any I doubt you've tried to work any, so I'm not asking that. But as you read through them, are there any words you're like, I don't even know what this question's asking? Like, forget how to do it. I don't even know what it's talking
Trying
about.
to tell me.
Critical numbers, intervals. Nine looks like one on the quiz. Probably means there's one on the test like that. Yeah. Uh-oh, that's not good. Yeah, I'll give them 9. I think that's the Shadow Forest nurse calling.
Uh-oh.
Yeah, I know.
Call.
Oh, I missed it. She'll leave a message. I'll call her back. It's all right. It's just a kid throwing up in the nurse, right? He'll be fine.
Call her back.
I'll call her back on the break.
In the 5 minutes?
Mm-hmm. We'll get out at 1:58. Yeah, 10 minutes. It's all right. My kid will be fine. Let's see. Which one? No, number 9. Sorry. The derivative of f is given by how many relative extrema does it have? I think the one on the quiz gave the second derivative and asked about points of inflection.
Yeah.
But it's kind of the same thing.
Yeah.
Because a point of inflection is where the second derivative changes signs. A relative extrema is where the first derivative changes signs. So I've got critical points at x equals 2, x equals 3, and x equals 4. Now, I can check all those intervals if I want to.
Or
How can I avoid checking the intervals?
you can count how many odd roots there are, or odd powers.
Yeah, 2 is an odd root, 3 is a double root. So 3 is not going to be a...
Consequential?
Yeah, well...
It's going to be consequential.
Yeah, I wouldn't say not consequential. It
this-
won't be a relative extrema.
Yeah.
Because if it's positive to the left of 3, it's going to be positive to the right of 3. Plugging in 5 wouldn't be difficult. Because 5 is bigger than all of those, so f prime at 5 is positive. And then I can basically follow my alternating rules. So this is f prime. So we would alternate across 4. We would not alternate across 3. We would alternate across 2. So this thing is increasing to decreasing. Be more specific. What's going on at x equals 2? It doesn't ask, but what's happening? That's a max. Because we changed from increasing to decreasing. At 3, we went decreasing to decreasing. So there's not a min or max there. At 4, we went from decreasing to increasing. So that would be a min. But it just asked me how many relative extrema does it have? Well, it has 2 of them. Increasing. Maximums, minimums. Increasing, decreasing, maximum, minimum. Turning the page to 13. And 14, for that matter. When it says absolute, min, or max,
The Y one.
there's what is the minimum and maximum value. So yes, you do want the y value.
So you also need to use the second derivative? Or like,
You're not going crazy because you're thinking of this, but what's the only path to land at an absolute extrema?
the table.
The table. So all paths start with critical points. So you start by finding first derivative, setting it equal to 0. But then if you want to land with absolute extrema, the only way to get there is with the table. So whenever you see absolute, that means table. So I'm going to have to Set the derivative equal to 0 to get the critical points. And then I'll make a table. What goes in the table? X values. Which X values? Negative 1 and 2, the endpoints. That's why we have to do a table. And then what else? Yeah, whatever critical points there are. We don't have to actually work the problem to figure that out.
But then you plug it into the original?
Yes, you plug it into f of x because you just want to know who's the highest and who's the lowest. Well, I guess in this case, just who's the lowest. And it says what is the minimum value. So the value you'd pick would be the y value. You would grab whichever one of these is the lowest. That would be your minimum. Min, max, increasing, decreasing, concavity, pictures. So it's a really long review, but you do have 2 nights to work on it. So my suggestion...
Get half done tonight?
Yeah, I would say do the odds tonight and the evens tomorrow. That would be my suggestion to you. Tomorrow I'll be thinking you're going to ask odd questions, but, well, that's a joke in there, but I'll let it go. But I'll answer anything tomorrow. But I would try to do a big chunk of them tonight, and then a big chunk of them tomorrow night or Wednesday night, because your test is Thursday. Tutoring is Wednesday and Thursday at B block.